to make this 1 over I to the 58. And then I'm going to do this little side deal where I go 4 goes into 58. And that's 18. And that's 4. As a remainder of 2. So whatever the remainder is that you get, that now means that I to the 58 becomes a new color. I'm not color coordinated. The day's going to go even worse than it already has. 1 over I squared. Okay, so whatever you get is the remainder. And the remainder could be 0, that's fine. Could be 1, 2, or 3. So once I have that, I can just say, well, I squared is -1. So that means this is -1. Or, once you've gotten it down to that level, yeah, I'm going to bring it back. I just need to get the Casio up to show you. Once I have it up here, I can put them both up together. Okay. So once you have the 1 over I squared, you can put your calculator in complex mode. And you can do 1 over I squared. A little tiny negative. You just can't type it in from the original number. This calculator will only do first power, second power, third power. So that's the most complicated one to handle because you have to change it. Now the next one, you don't have to do that first move. The next one, you just do the divide by 4 trick. So I go 4 goes into 32, 8, 0 remainder. So now that means that I to the 32 is going to become I to the 0, anything to the 0 power is 1. And that's it. So you either just directly write it with the remainder, and then you can type that into your calculator if you don't recognize what it is. Or you have a negative sign, so you put it under, you do it, and then you type it. Yes?
For problems like that, if we have any like that on the test, if we already know that 32 goes in, 4 goes into 32 times, you can just...
Yeah, you really don't have to show me. I'm doing that so that just consistently, that could have been, 157. Just to show you the method. The method works no matter what. Yeah, obviously 4 goes into 32, 0, you can do it in your head. But 4 to 101, I don't know, I can't do it in my head. But yeah, so the next two are the same thing. They might come out to be a different answer, like one will be an I cubed or something, but same idea. And then this one you've handed me with a bunch of decimals. You should just be able to type into your Casio directly. So 0.02, 0.05, and 0.14, and 0.11i, and then 0.07, 0.07. You have a Casio, right? You won by the weekend. Okay, so all I have to do is type these all in. I don't actually even need the parentheses. So I got 0.02 plus 0.04 with an I. Actually, I don't have to do anything if I just hit the A and G key with an I.
Bless it.
Plus 0.14, minus 0.11 I. Plus. No, because they're all being added. I wouldn't need the parentheses if there was a minus sign in front, because I would have to distribute it. But since they're all added, you could type them in if you're a complete kind of person. Oh, wait a minute. Since I took so much time trying to get this thing up, I'm trying to save a little time here. You guys would not let me do that. Okay, plus 0.07 plus 0.07i. And this little arrow here means it's scrolled off the side of the screen, but if you wanted to, you could use this arrow and go back and double check and make sure you typed it all right. Because that's usually, as you just saw me typing, where the mistakes are, okay? So then you just hit equals. So that is not the decimal version. Right here, where it says S double arrow D, that says screen to decimal. So you tap that, and there's a decimal version. So that means all the eyepieces cancel, and you just have that. So if you're doing this in Connect, that's the answer, but they might have said write it in A plus BI form.
Yeah.
In which case you would need to write plus 0I. Okay? To give it to them in their picky ass. I know. Some bitch did all that. Who she was. Clearly. She was not getting any at the time she wrote that. Sad state of affairs. Or not. Okay. Into your Casio. Your Casio will handle the square roots, will handle the negatives, everything. So, parentheses, 6 minus square root negative 3. Okay, I have a new theory. Because I want to correct. Again, get answers. I didn't say they were going to be right. 3 minus square root of negative 3. Out from under in parentheses. You do have to be careful when you're putting on the back parentheses. If you don't arrow out, and the little parentheses will sometimes look like it's coming underneath there, it'll give you an error message. So you have to use this arrow key to get out from under that bar.
That was just happening.
And then it's a big one. That's, you know, that's the reason you do the homework now, so you find out these weird ass things, and it doesn't happen to you on the test. And you're going, what the hell? You type it in 50 times the same way. There we go. And for those of you using TIs, you would be doing a lot of foiling. And have fun with that. That's all. Yes, sir.
I got 21 minus 3 squared root 3.
You did or your Casio did? Your Casio.
You got mixed up with the number.
Yeah, you just wrote it down wrong.
Always believe your Casio over me. That's number one. Okay. Yes, oh my God, my ass is like sliding down this. I'm like, hell. Okay, now they told me I have to like drag them. Okay. You know, my ass will keep in the air while I'm doing that. Okay, maybe better. One of the crazy chemistry professors came around our office today asking us to sign a petition about this room, thing she wants fixed. Okay, so this first of all, so it doesn't whack you in the head. Okay, and the document camera, like if I want to put something here to show you guys, I mean I have calculator emulators on here, but if I brought a calculator to class and I wanted to put it on the desktop and show you, these lights, you can't get them adjusted to show the desktop. So you can't use the document camera, and it doesn't show up on the screen. So she had a whole list of things. I'm like, I'm just signing, and you're leaving, right? Says, I know, but you think I'm crazy. Oh, you want my signature on there? Is that what I'm signing? Because, yeah, I'll sign that. Anything else? You ready for something new and exciting? Okay, so I'm sad to tell you, this is ridiculously easy in the beginning, and from hell at the end. So guess which one's on the test? From hell, okay. Because the beginning here is 1033, the class below, where you have one single square root. You square both sides, you get a quadratic equation, and you solve. The college algebra version is 2 square roots. So it's the same procedure, but it has to be done twice. These problems are insanely long. This is probably the longest question of the test. I mean, it's just one equation, but as far as the actual amount of space it takes up, it's like you have to do a problem twice, basically. So they're amazingly long, like 20 lines. Okay, so I'm just warning you, don't think, oh, I'm doing something wrong, this is taking too long. No, it's, you know, make yourself some snacks, a little drink. Okay, comfy pillow, and settle in. Okay, so, I'm giving you the procedure there, which you can certainly read, but I'm just going to talk you through it, because I know you like to hear me talk. Or I think you like to hear me talk, so that's all that matters. So, first thing is, no matter how many I may have in here, square roots or cube roots or whatever they are, I need to start by isolating one of them. This one only has one. So it's like you would get x by itself, I'm going to get the square root by itself. So that basically just means I'm moving the 3 over there. So I start off by saying 2x plus 9 equals x plus 3. Okay. So in order to get rid of the square root, I have to square. You square a square root, it goes away. I do the same thing with cube roots or fourth roots. Whatever the radical is, I raise it to that power. So in this case, I'm going to square both sides. Notice that this is the side, not the term. In other words, I don't square the root, square the x, square the 3. I don't treat those as separate pieces. I square one whole side and one whole side, which means that over here, I apologize already, this is FOIL. Okay, this is x plus 3 times x plus 3. So it's first, outside, inside, last. And I can put these two together. Now, if you know what you're doing, you don't actually have to do FOIL for what are called, these are called perfect square trinomials. You have a pattern to these that happens all the time. And here's what the pattern is. Okay? You're going to use this 3 times. You're going to square the x. You're going to say 2 times x times 3. 2 times x is 2x times 3 is 6x. And then you're going to square the 3. It was almost too weird, wasn't it? So, it's like I'm talking louder, so I'll write bigger, okay? So, square the x. And then use the second thing is 2 times x times 3. Okay, so you square it, 2 times x times 3. And then the third thing is square the 3. So you can just do that in your head. You don't have to write that step down, but that's what you're thinking. You square the x, 2 times x times 3. So there's your 6x. And square the 3. It's a mnemonic device. Remember, a trick, if you will. You don't like that? You can do for it. But what I'm telling you is it can save you some time, because that means if I'm doing this problem, I don't have to go off to the side and do FOIL to figure it out. I can just do this. I square that side, it's 2x plus 9, and this is x squared. 2 times x times 3 is 6x, and 3 squared is 9. So it's a little cleaner look if you learn that. You don't have to go off to the side and do something and then come back. Yes, sir?
And for what numbers does this work?
Everything.
Okay, so there's a negative.
In that it's going to have a minus. So, like if you had x minus 4, 2 times x squared, 2 times x times negative 4, negative 8x, and then negative something squared is still going to be positive. So it's all going to be positive. You just have a negative sign in the middle. Fractions, anything. Okay, so you can go off to the side and do your FOIL, or you can remember that device, you just have to practice it. And then you just write it underneath, okay? So now I have an equation to solve. Now I have a quadratic, okay? So as we've seen, we have a quadratic to solve. You want everybody equals 0, that's what we did last time. So I'm going to put everything over here because I like x squared positive. You can drag this crap anywhere you want. So it's going to be x squared, 6x minus 2x is 4x, 9 minus 9 is 0. Now obviously, you can do that in your head. If you can add and subtract integers in your head. Yes, sir. Not when I put this over here. There's a plus 9 there, but then I dragged one over. So it's minus. Yes, sir.
X squared plus 4 passive.
Yes, you can. So now, it's not clobbering time, it's Saskia time. You can just plug that into your Casio and get the 2 answers. Or you can factor it. I mean, these are going to be factorable, but you don't care. In other words, I'm not studying to see if you can solve a quadratic here. I want to know if you can solve the whole thing. So that little piece at the end where you just type it in your Casio and now you say x is 0 and x is 4, that's fine with me. You know, if you factor it, I'm sorry, negative 4, you will get x equals 0, x equals negative 4. If you plug it into your Casio, you would have to say a is 1, b is 4, and c is 0, because there is no constant term there. And your Casio would give you an x1, x2 answer. That would be those two numbers. Okay? Oh, we're not done yet. I know. It's like that bad girlfriend or boyfriend that you thought you got rid of, but they just keep calling. Okay. This problem just don't end. You're like, oh my God, I gave you the answer. That's the answer. But wait, no. Okay. So here's a problem. There's always a problem. Some answers may not work. They're what you call extraneous solutions, which is a big word which means may not work, okay? What happens is when you square something, you wipe out the difference between negatives and positives. In other words, if my original number had something negative in it, after I square it, it's now positive. So you have changed the equation. Your answers are in this list, but you never know if they're all going to work. Maybe one works, maybe both work, maybe neither of them work. So you always check. Okay? When you have an even root. So if you square both sides or the fourth power, whatever, you always check. So that means I go back to the original equation. Square root of 2x is 9. Square root of 2x plus 9 minus 3 equals x. And I check what I think are my solutions. So I check x equals 0. I don't mean you check. I mean, you know, your friend checks. Okay? So I go square root of 2 times 0 plus 9, I'll come under, minus 3. So there's a left-hand side, and that gives me 0, which is what I get here. So I'm going to get 0 equals 0, and that one works. And the reason I typed it in like that for my Casio is because now to check the other number, which is negative 4, I can edit that. I just go back with my arrow and take out the 0 and put in negative 4. So I don't have to type the whole thing. So this is now negative 4 and negative 2. So when I check x equals negative 4, I'm going to get negative 2 equals negative 4 means no. So my only answer is x equals 0. Okay. So this is not too bad. I mean, you know, it's a few steps, but it's not hard. Okay, so do one more of these easy ones. Remember, this is not the test question. This is the warm-up. You're just practicing not the test question. Okay, so here we go. Get the square root by itself. The 1 on the other side. Wrap both sides and square it. So over here, it's 10x plus 5. Here, it's 2x squared, so that's 4x squared. 2 times 2x is 4x times 1, still 4x, and 1 squared. Which you can just do like that. So square it, 2 times this, square it. Like you use that little 2 3 times. Square it, 2 times this, square it. Or you go over here, because you're old school and you have to see it. And you multiply it all out with FOIL. And surprisingly, you see the same damn thing. And if you're the kind of person who's constantly amazed at life, maybe that'll entertain you. Look, it happened again. One more time. Square it. 2 times this, square it. That's how you use it 3 times to get those units. Okay, so now I'm ready. I have my quadratic. Same deal. I'm going to move the stuff over here. And again, you can do this subtraction when I bring these over in your head, or you could write it down. Doesn't matter. So 4 minus 10 is negative 6. 1 minus 5 is negative 4. And Inchhill. Or you can calculate. I'll do it in Casio for those of you who were not here to see this miracle occur last time. So mode is equation. I'm going to solve a quadratic, number 3. I have 4 in front of the x squared, negative 6 in front of the x, and negative 4 as my constant. The two answers are 2 and negative half.
And those are like ABC.
That's ABC. And see, your Casio prompts you for that. When you first see the equation, they're telling you what A, B, and C are. See how they have it written? Ax squared bx c equals 0. They're telling you the equation has to look like that. Everybody on the same side, set equals 0, A is in front of x squared, B is in front of x, C is a constant. And then when you go to put it in, they prompt you again. They have it there. You just move. Every time you put a number, you say equals, and you go to the next field. Okay, so now I'm going to see if they work. And remember, you can factor those if you like. So here's what I'm testing. These two. So I'm going to test x equals 2. So I have square root of 10 times 2 plus 5 minus 1 equals 2 times 2. So this is what I'm going back into the original equation, and I'm trying to see if those two sides are going to be equal. So I can type the one on the left into my Casio and see what I get, or I can just do it by hand. Probably do it in your head. That's 20 plus 5, that's 25. Square root of 25 is 5. 5 minus 1 is 4. And believe me, I who can barely do arithmetic, if I can do it in my head, you can do it in your head. Okay? As you've seen me try to do arithmetic today. Now, x equals negative 1/2. That's gruesome, but it doesn't matter. Remember, what do you care if it's a fraction? We care it's a grotesque fraction. You have a calculator. Mr. Cassio. Mr. Cassio loves fractions. So once again, I'm questioning. I'm replacing the x's in the original equation with my answer choices. So that's minus divided by 0. That is -1. Because that's -1. So I have two answers this time. They both work. Oh, yes. Oh.
So you got a 4 in the first one, and that works because it has 2 goes into 4.
Yeah, that works because the other side is also 4. 2 times 2 is 4. In other words, you're going to put input both sides. It's just that usually one side is super ridiculously easy, so there's not much input. You just do it in your head. Usually most of the trauma is on another side. Yes? Uh-oh.
Professor,
Smell smoke? I smell smoke?
can I ask a question on this? When we put into the equation the a, b, and c, we put c -4.
Yes.
In the answers, we don't put that because I got like a 3/4.
And you input something incorrect.
I put something incorrect. Okay.
Maybe you put in a positive or something. I don't know, but something.
Nothing should come up for c then? It should just be two answers, the 2 and the...
No, you input C.
Mm-hmm.
In other words, here, I've got, when I'm on this screen,
Mm-hmm.
I have 4, enter, -6, enter, -4, enter. And now they're all in, so I hit equals again. Let me get my 2 in.
Mm-hmm. And if you hit equal again, it gives something else?
Now you're getting information that we're going to see later in this course.
Okay, so it's just the first two after.
This is the graph of a parabola.
Okay.
That's telling the x value of the vertex of the parabola, and that's telling you the y value of the vertex of the parabola.
Okay. So just the first two.
I just said blah, blah, blah. Because we're not there yet.
Yeah.
I kept that curtain shut. All will be revealed, grasshopper. Just not now. I have a plan to guide you through the wilderness that is college algebra. Okay. Dum, dum, dum. Now, for this little puppy, I have a video you can go watch if you'd like to see this kind of thing repeated endlessly. Or you have ones in your textbook also, and you can remember, open up that ebook. If you do one of these problems and you get it wrong, you can go to a link to text, and you can look at the examples, and you will see there are a lot of videos in there done by Julie Miller, okay? Who is the most calm, serene, helpful person ever. That's why she does videos. Me, it would be a little different kind of video, okay? Plus, they don't let you curse, okay? So we'll tell you. It will be a lot of editing, okay? So, you know, you can zap it on your phone if you need to see it right now, okay? When you have the notes, or you can just click on that, you know, control click in the Word document. Okay. It's not this exact number, but it's this exact style with 2 radicals in it. Okay, so the directions remain the same. One radical needs to be by itself. Okay, I pick you because you're the first one, so what the hell? And I'm going to move the other one to the other side. Before I was moving like a single number or a single variable, now I'm moving a radical. Same deal. So this becomes square root of 3x plus 1 equals 1 plus the square root of x plus 4. So here's our first little step into hell. Okay? I'm going to wrap this, and I'm going to square it. So I square over here, and I get 3x plus 1. Now, I can use a little trick I've been showing you to square here, And it works here just like it did before, but you're not gonna like it. So I'm gonna go real slowly. 1 squared is 1. 2 times 1 times the square root of x plus 4 is 2 square root of x plus 4. X plus 4 squared is x plus 4. Oh. Let's see, you follow me with the numbers, now you're gonna have what? Yes. This is you didn't believe your Casio when I told you?
Oh.
You didn't believe your Casio when I told you this before?
No, I didn't, I was trying to calculate in my head.
Okay. Yeah, that's gonna be 25 under, square root of 25, square root of 25, so that's 5, that's 5 right there. Okay, I'll do it again. Squared 2 times 1 times this, which is 2 times the square root. And then this thing squared, which is x plus 4. And if you don't like that, and if you're old school, you say, no, 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 I need to see all the steps. Okay. Then you would do what we were doing up there. You would write this twice. This makes it look way worse. And you would FOIL these. So it'd be 1 plus the square root of x plus 4 plus the square root of x plus 4 plus the square root of x plus 4 squared. That would be 1 plus 2 square root of x plus 4 plus x plus 4. Personally, I've learned the trick. Okay? Does it get you there without having to see more mess? Yeah. Yeah. Square the first one. You know, use the 2. 1 squared, 1. 2 times 1 times the square root. And 1 is 2 times the square root is 2 square root. Square the, so when you square it, square root disappears. Just x plus 4.
Why don't you do that for the other side too? What is it?
Because it's only 1 square root. The difference here is it's a sum. That's why, see back here, when I do square the single square root, it just pops out. That's what's happening on that side too. Okay. Believe it or not, that's the place everybody screws it up. Yes?
So you have the shortcut on the videos?
Yeah. Now, I'm thinking no. Because when you make those videos, see the videos are for the whole book, they're like national, so it's kind of a hinky little shortcut. It works, but you don't usually put kind of stuff like that in videos because some math teachers will think and go, oh, how can you make that up for them? It works. Okay. You know what I'm saying? But you don't want that in print, you know what I'm saying? So the reason it works is because what we're doing is this. That's in the videos. That's the formula for multiplying a perfect square trinomial. Square the A, 2 times A times B, which is what I'm saying. 2 times A times B, and square the B. Okay? It's just that it's presented in the book as just a formula without giving you that little trick of using this 2 3 times, which I think visually anchors it better in your brain. You know, square it, 2 times this, square it. But this is what it is. Square it, 2 times A times B, square it.
So you square A,
Yes,
and then
use the 2 again,
the two, so just the number 2 times the A
times the b, yes,
and then you add B squared.
and then you square the b. So you square the front, 2 times a times b, and square the back. It's like use that exponent 3 times. Use it in the front as an exponent, in the middle as a for the product, and at the end as a square law.
Okay, thank you.
I was kind of confused on this one here. You square rooted the 1,
Yes,
and then you square rooted just the square root itself, and then what was underneath it? Or,
that's the same thing that's happening over here. When you square a square root, you get what's underneath.
okay. But then how'd you get the other plus x4? Because you just square
That's what x plus 4 is. That's what's underneath.
Okay.
See, this whole mess squared gives me the underneath part. Just like this whole mess squared gives me the underneath part. It's a visual.
Because you squared the square root.
I squared the square root. Painful stuff. Okay? So, you realize what the problem is now, right? There's still a freaking square root in there. So that means I gotta do this whole thing again. I have to get that square root by itself, do the whole square process again, and finally get rid of it. That's why I'm saying these are so long. It's not that I'm doing more complicated per se, I'm doing the same thing twice. So it's twice as long, okay? So now you have to be by yourself. So I'm moving everybody to that side to leave it by itself, okay? So I will have, oops, can't do it black, let's do it blue. Come here. So I have 3x plus 1 minus 1 minus x minus 4 equals 2 x plus 1. So those things, the 1, the x, the 4, I'll move over here. So I have 3x minus x is 2x. 1 minus 1 is 0 minus 4. Anything about that? Look, if you want to fix. You know, all those 2's are annoying me. You don't have to divide out 2, but everybody's got a 2, you know what I'm saying? And I'm getting ready to square it. So if I leave them in there, the numbers are going to be much bigger than they have to be. So normally at this point, if I can spot something to make the number smaller, I would do it. Whoops, sorry. Don't worry. Maybe shouldn't. So I've got x minus 4 equals square root x plus 4. Okay. Yes.
Okay, so since the 2 for the radical, they all have a common denominator, so it factors out easily. Let's say it was a 3.
Then you wouldn't do it.
So you would leave it. You wouldn't try to get rid of that number.
No, because then you'd have to deal with fractions. I'm only doing this because it makes my life easier. If you left it in, when you go to square both sides, you would have to square that number in front also.
Why don't you square up this, like, why don't you divide the square root by 2?
Because it's each piece, 2 square root is 1 term.
Okay.
So either the 2 goes under the 2 in front, or it goes under the square root. It's useless under the square root. I brought it up in my head because they're all even. You don't have to do it. You could leave it, you could leave it like this. If you think you're going to get confused over what to divide by, just don't divide by anything. Just go right to this step. That's fine. It's just that you're going to have slightly bigger numbers. That would be more of an issue if you didn't have a calculator, because bigger numbers usually means it's harder to factor, but if you're gonna use a calculator, it doesn't matter how big the number is. Okay? So either way, I divide it out or I don't. I have to square both sides again. So here we go. I have x squared. X squared, 2 times x times negative 2, negative 4x, negative 2 squared, positive 4. Or you can. Yes, sir.
Did you say that negative 4x part of it?
It's 2 times x times negative 2. Still this times this times this with the sign. And whatever, it doesn't matter what the sign is here, after you square it, that back end is always going to be positive, because you squared it. And over here, x plus 4. Okay, so I'm starting to see the end. Okay, this long journey. So now I've got my quadratic. I'm going to bring the x and the 4 over here. X squared minus 4 minus x is minus 5x. 4 minus 4, you're just going to go away. You can immediately run to Casio screening. Or you can factor that and get your 2 answers. After all. And then you would have to check both of them. We this time go back to the original equation. Do square root 3 times 0 plus 1 minus the square root 0 plus 4. And you wonder that equals 1. Square root of 1 minus 2 is negative 1. The answer is no. So x equals 0 would work. Notice that's the original equation. I'm way up here. Before I squared, before I moved anything, you go all the way back to the beginning, before you start the decimals. And then I check x equals 5. So that is the square root of 3 times 5 plus 1 minus 5 plus 4. And it's supposed to equal 1. Maybe. So that's 51 16 is 4 minus 3. So that's 1 equals 1. And that one's yes. So I'll dump you. And keep you. This is like the last question on the test with a lot of room. We're doing one like this. How many of these do you think you can do on a test?
That's why.
Trust me. Oh no, there's a ton in homework. The problem with this test is you can't hesitate. You know, too many people get caught up with all these different techniques that you throw together. You need a lot of practice so that you're not, when you see it, you know immediately what to do. Okay. I'm gonna skip this one for now because we're running a little short on time, and I want to make sure I get to the ones that are different. And then if we have time, I'll come back and I'll do that one. Okay. That one, by the way, I wouldn't have to move anything. I could start right out of the gate doing that because I already have one by itself. So it may be that you don't have to move anything, right? You don't always have to move anything. Okay. So, what if I have these things with exponents? Now, fractional exponents are radicals, okay? When you have x to the a over b, that is the bth root of x to the a. That's what it means. So x to the 1/2 is the square root of x. X to the 1/3 is the cube root of x. So these problems in this section are in there with the radicals because they are radicals. They're written differently, but they are radical problems. So for example, it's kind of hard to see these numbers, I know. This is x to the 3/4 equals 2. If I were to write it in radical form, it would look like that. The denominator is the index of the radical, and the top number is the power. So if you think that would make it clearer, you could actually write it that way, because now it looks like the same radical problems we were doing. So how would I get rid of the fourth root? Raised to the fourth power, right? If I have a square root